Hi all. This is the second video of the third class. Now let me start with reviewing the previous class materials. So it is the first chapter of statistics. So we learned how to define probability and how to characterize randomness. What we learned, we start from this idea. When you define a probability, you also have to define an experiment, the underlying experiment, and the event of interest you are attaching the probability to. So we have to think about experiment and event. Experiment, when you think about experiment, what I emphasized was repetitions. You have to imagine repeated experiments, and their outcomes are your data. You observe the outcomes from repeated experiments, and that's your data. And we call the number of repetitions as the sample size. So the term sample size, is one of the most important term in statistics throughout the field. So, and this is an example. As you increase the repetitions, number of repetitions, then your probability will approach to the true probability. Here, then it implies a lot of things. Implicitly, it defines many things in a natural way. First, we can think about the truth. What is true probability? And it is not easy to answer, but we define it as the probability we approach to when the sample size approaches to the infinity. We call this the population. Population is everything we want to know, and in contrast, the sample is what we have. So the population is the limit when the sample size converges to the infinity. But of course, it is not available. We cannot repeat the experiment infinite number of times. So it is not impossible, but we want to know about this. So instead of the population, we observe the sample, a sample, and using the sample, we would like to infer about the population. That is statistics. That's statistics. And an example of experiment is survey and time series. In time series data, you have to think of a hypothetical, impossible experiment. But we need to think about something like this. And if you look at the data, it's just a bunch of numbers, and we need to summarize them. That's one way to do that is the probability distribution table. So you know how to calculate the probability. It is easy. It is the ratio between the frequency to the sample size. And calculating probability is not a big deal. And what we need to distinguish is the difference between event and outcomes. So event may be a single outcome, but event may include multiple outcomes. So and it is convenient to use event when you define probability instead of a outcome. It is clear when you think about multidimensional data. So if you think about this data, it's a real data, and we can make a 2x2 probability distribution table. It is a 2x2 probability distribution table, and from here you can calculate any probability because it shows all the outcomes probabilities. And the basic principle is that the probability of an event is the sum of probabilities of the outcomes included in that event. So an event may include multiple outcomes, and the probabilities of these outcomes sum to the probability of the event. So so we define notation for two events and probability, and we learned complement and union and intersection. These three operations are very common and important because now we are considering only 2x2 case, but of course, in reality, your data would be much more complicated than this. You may have more than two variables and more than two outcomes for each variable. But still, when you understand, if you understand complement, union, intersection, then you can express any kind of event using these three operations and basic events. So these are important important concepts, important rules. And also we learned an important rule, the addition rule. In some sense it's trivial, and we would like to, the point of this rule is to express the probability of the union of two outcomes as the sum of two basic probabilities, the probabilities of basic events. But there is a problem. If it's not simply the sum, but you have to subtract something that is um, uh, that's the minus probability of intersection part, because when you take the union, you include all the outcomes either in F and in H. So there may be some outcomes that are included in both of the events. So when you simply sum two events, the outcomes included in both events are calculated twice. They are added twice. So you have to can subtract the double counted outcomes by subtracting the intersections. The intersection is the outcomes that are included in both of the events, so they are double counted. So we subtract the intersection part. And if you don't like that part, then alternatively you have to make an assumption. You have to assume that there is no double counting, which means the probability of intersection is 0. So it is it is a special addition rule, but it does not apply to a general case. You need to verify this assumption. And in this special case, when the special addition rule holds, then we call these two events as mutually exclusive. If two events have 0 intersection, then they are said to be mutually exclusive. These are what we learned last time, and today we will study a little bit more about probability distribution using the same example. Today we are going to learn the joint probability distribution and the marginal probability distribution. I am going to call them simply joint distribution or marginal distribution instead of joint probability distribution. To define them, the joint probability is the probability distribution about multiple variables. Like in our example, we consider two variables, gender and health insurance coverage. So if you make a 2x2 table, then you are showing the probability of these two variables at the same time. Thus, it is a joint probability distribution table. But the marginal probability distribution is about only a single variable. So in our example, if you only take the gender, then you can make a simple 2x1 probability table then that is a marginal probability distribution table because it is about only one variable. And similarly, if you consider probability for health insurance coverage, that is also a marginal distribution because it's also a single variable. When you have more than two variables, then still the definition is similar. Joint probability distribution is about multiple variables, could be more than two, but marginal distribution is usually about one single variable. So that's these are what we are going to learn. Actually, we have seen all of these. So I'm going to continue in the next video. Thank you for watching and see you in the next video.